Hey everyone! Today we're going to be learning about different units that we're going to be using in physics. So we will be focusing on time, distance, and mass. For time, the typical unit that we use is seconds, and it's abbreviated with an S. For distance, we use meters, which is abbreviated with an M. And for mass, this is a little different from your other science classes. We use kilogram, which is abbreviated kg. This is different from probably what you're used to in chemistry when you measure in grams. So be careful on this one. We use a standard unit of kilogram for mass whenever we're working with different masses in physics. In order to convert between different units, you're going to see different unit prefixes. So you're going to get this table on any test or quiz that you ever have to take in physics, and you just have to know how to use this table. So let me explain what this table looks like. In the first column, you're going to see all the names of the prefixes. So we have giga, mega, kilo, centi, milli, micro, nano. In the middle, you'll see the base unit. So this is your second, your meter, or your gram. In each of the second column, you'll see the abbreviation for that prefix. So if we're using meters, it would be gigameter, megameter, kilometer. You would just fill the M in there, centimeter, millimeter, micrometer, nanometer. Or if you were using seconds, you would fill the S in. If you were using grams, you would fill the G in. Now, each of these is a 1. So this is 1, let's say we're using the meters again. 1 gigameter is equal to 10 to the 9th of the base unit meter. So you could go ahead and fill in meters on all of those if that's what you were working on. If you're working on a length or a distance, you could fill in meters on each of these, and you could put an equal sign between each one. So each of these is just a 1. So it's saying, like, another example, 1 centimeter is equal to 10 to the negative 2 meters. 1 millimeter is equal to 10 to the negative 3 meters. As a quick reminder on your exponents with scientific notation, 10 to the 3 means like 1 times 10 to the third. And that means that you are moving the decimal place over 3 spaces. So 3 spaces to the right, since it's a positive 3. So 1 times 10 to the third is equal to 1,000. So 1 kilometer is equal to 1,000 meters. With a negative exponent, for example, 1 centimeter equals 10 to the negative 2 meters. When you have a negative exponent, that means you're moving your decimal place to the left. So if we're moving this to the left by 2 spaces, you get 0.01 meter. So 1 centimeter equals 0.01 meters. All right, let's do some examples. You guys have already learned converting units a few times, but we're going to do it again. And we are going to do 5 practice problems here, 5 different examples. The first one, what we're going to work on is changing a unit with a prefix back to the base unit. So this one's saying to convert 12.5 kilometers to meters. The first thing you're going to do is write down the conversion factor. So when you see kilometers to meters, you're going to find the kilo in your table. If you want to fill it in, kilometers, 10 to the third meters, it's saying 1 kilometer equals 10 to the third meters. That's called your conversion factor. The next step is to write the given amount, 12.5 kilometers over 1. the 12.5 kilometers, whatever the given is, the given amount will always go in the numerator. Next, you multiply by your conversion factor. So your conversion factor is 1 kilometer equals 10 to the third meters, remember? You want to make sure that you set this up in the right order so that the units will cancel out. Remember, when you're multiplying fractions, it can only cancel something on the numerator with something on the denominator. So if we want those kilometers to cancel out, we have to put the 1 kilometer in the denominator. That means that the 10 to the third meters has to go in the numerator. So we decided to put 1 kilometer in the denominator so it would cancel. And that means 10 to the third meters goes in the numerator. Whatever you're trying to convert to, since we're trying to go 2 meters, that's always going to be in your numerator as a tip for you as well. All right, so with fractions, we know we can multiply straight across when we're multiplying fractions. We can cancel out any common factors, so that's why we can cancel out the kilometers, because it's a common factor between the numerator and the denominator. And when we multiply this straight across, we get 12.5 times 10 to the third meters. On the bottom, we have 1 times 1. The units are gone, so we just have 1 on the bottom. You guys know you don't really need to write a 1 on the bottom. Dividing by 1 doesn't change a value, so we can just go ahead and get rid of that. But this is not in correct scientific notation. For correct scientific notation, you can only have 1 digit before the decimal. This has 2 digits. It has a 1 and a 2. So we can't have a 12 here. We can only have 1 digit here. So you have some options. You can go ahead and multiply it by 10 to the third. So remember we said if it's a positive, that means you're going to move your decimal to the right by 3 spaces. So we would get 1, 2, 5, and then we have 2 extra zeros here. So 12,500 meters. Or your other option is to write this as, if you want, we can move this decimal 1, 2, 3, 4 places and still keep it in scientific notation. So it would be 1.25 times 10 to the fourth, because we moved it 4 decimal places, meters. These would both be good answers. You have the option of either 12,500 meters or 1.25 times 10 to the fourth meters. Okay, on this next example, we are converting a base unit to a unit with a prefix. So it's telling us to convert 382 meters to kilometers. So first, just like before, we're going to go back to our table and find our conversion rate. This is the same conversion rate as we used before. 1 kilometer is equal to 10 to the third meters. So first, let's write down our conversion rate. 1 kilometer equals 10 to the third meters. Now we're going to do the same exact process. We start with the given value on the top over 1. We multiply. This time, since meters is what we're given, we want to put the meters in the denominator so that it'll cancel out. We know that it's 10 to the third meters, so 10 to the third meters has to go on the bottom, whereas we're trying to convert 2 kilometers, so the 1 kilometer goes on the top this time. So notice it's actually the reciprocal of what we did the last time, because instead of going kilometers to meters, we're going meters to kilometers. We need the meters to cancel out this time. We want to end our answer in kilometers. So multiply straight across, just like we did before. 382 times 1 is going to be 382 kilometers. On the denominator, 1 times 10 to the third is just going to be 10 to the third, and the units are gone there. But now we can't keep our answer like this. We can't leave this as 382 over 10 to the third. So in order to put that into proper notation, you have a couple options. If you're good at your math exponent properties, you remember that you can move something, a base with an exponent, to back up to the numerator by making it a negative exponent, the opposite exponent. If it's already in the denominator and you move it to the numerator, the exponent becomes negative. So we know now we can move this decimal place backwards to the left by 3, 1, 2, 3, giving us 0.382 kilometers. But if you're not quite so savvy with your exponent rules, you can always use your calculator in physics. So what you would type in is the 382 divided by 10 to the power of 3 and press enter, and you'll get the same answer, 0.382. And remember to always keep those units on your final answer. Okay, so far we've just done base unit to a prefix and prefix to a base unit. Now, what if we have one prefix that we're trying to convert to a different prefix? So for in this example, we're trying to convert 0.116 megaseconds to microseconds. So there's not a conversion, there's not a row in the table that has both megaseconds and microseconds. You're actually going to have to do 2 steps if you're converting from one prefix to another. So first, let's find the mega. Here we see that 1 megasecond is equal to 10 to the 6th seconds. So let's write that down first. 1 megasecond equals 10 to the 6th seconds. Then we need to find microseconds in our table. So now let's look at this row. We see that 1 microsecond equals 10 to the negative 6 seconds. Let's write that one down. 1 microsecond equals 10 to the negative 6 seconds. Just like before, we start with the given value in the numerator. So 0.116 megaseconds over 1. Since we're starting out in megaseconds, we want to use our conversion rate that has megaseconds in it first. Just like before, we want the megaseconds to cancel out. So we need to put the 1 megasecond in the denominator, so that the megaseconds will cancel out. So whatever started on top before goes on the bottom now. We know 1 megasecond is equal to 10 to the 6th seconds. Since 1 megasecond is equal to 10 to the 6th seconds, you're technically multiplying by the same thing on the top and bottom because those are equal to each other. Remember, you can only multiply by 1. So this is allowed. It's not going to change the value of our number. It's just going to change what it looks like. So this is our purple conversion factor. Now we need to use our blue conversion factor. So now just focus on this purple fraction. Now we have seconds on the top. So we want to make sure that we put seconds on the bottom so that it'll cancel out. Remember, whatever was on the top before, we put it on the bottom on the next fraction so that it'll cancel out. If we have the 10 to the negative 6 seconds on the bottom, that means we have to put the 1 microsecond on the top. So that fraction is our blue conversion rate. And that cancels out our seconds for us. So now our last fraction has the microseconds on it. Whatever you're trying to end up in should be on the top in your last fraction. So if you're converting to microseconds, your last fraction should have microseconds on top. Okay. Now we're ready to multiply straight across. We have 0.116 times 10 to the 6th times 1. We don't really need to worry about the times 1. Let's just write this down for now. 0.116 times 10 to the 6th on top. And our units are microseconds. On the bottom, we have 1 times 1 times 10 to the negative 6. We don't really need to worry about times 1. And all the units are canceled, so we just have 10 to the negative 6 on the bottom. Okay, again, you have a couple options for this. If you're good at your exponent properties, just like before, you know that if you're moving this from the denominator up to the numerator, you get the opposite exponent. So we already have the 0.116 times 10 to the 6th. But then if we move the 10 to the negative 6 up to the numerator, it becomes the opposite exponent. So the opposite of negative 6 is going to be positive 6 microseconds. And then you can look at this and say, okay, 10 to the 6th times 10 to the 6th, those have the same base. So I know that I can add their exponents and make that 10 to the 12th microseconds. But I know I shouldn't have a 0 here on scientific notation. So in order to move that decimal place over by 1, I know I'm going to have to make this 1.16 times 10 to the 11th microseconds. However, like I said before, if you're not super great at your exponents, it's okay. This is physics, so we can use our calculators. Obviously, the math teacher in me wants you to know your exponent rules, but that's not our worry here. We're more worried about converting these, so we're going to go ahead and type this into our calculator. We'll go times 10 to the power of 6 divided by, let's put this in parentheses, 10 to the power of negative 6, and press enter. Now our calculator looks a little weird. It has that E in it. That E is just what your calculator gives you instead of times 10 to the power of. So that 1.16 e to the 11 is really the same thing as this times 10 to the power of 11. So if you need to make a little note that in your calculator that's going to say capital E so that you know to write that as times 10 to the power of, you're not going to write E on your final answer on a quiz or test. You're going to write times 10 and then put the power 11. Okay, so far we've done all just converting units. We haven't seen anything that has 2 units in it, like this next example, which is a speed unit. We have meters per second, so notice that has distance units and time units in it. And we're converting it to kilometers per hour, so that's also another distance and time unit. Just like before, you're still going to start out with your given in the first fraction. This one's a little different though. It's not just 5.6 meters over 1, it's 5.6 meters over 1 second. We want to convert both the distance to kilometers and the time into hours. Notice that neither of these units match. We have to convert distance and time. So it's kind of up to you. If you want to just convert one thing at a time, you can, or you can do it all at once. So let's focus on just doing one thing at a time. Let's focus first on converting meters to kilometers. That's our distance unit. So let's go up to our table and find our conversion rate for meters to kilometers. We've already done that a couple times today. We know that 1 kilometer equals 10 to the 3rd meters. So let's write that down. Need a little space here. 1 kilometer equals 10 to the 3rd meters. So I know that I'm going to have to put my 10 to the 3rd meters on the denominator so that my meters will cancel out, meaning that my 1 kilometer belongs on the top. So notice that I'm just taking this conversion factor, putting one of them on the top, one of them on the bottom. And the way to decide is to make sure the units will cancel out properly. So that's going to convert me to kilometers per second. That's going to convert my distance units. But I also have to convert my time units. I also want to convert seconds to hours. Everyone should know the conversion rate for time, seconds, hours, minutes. If you don't know how to go directly from seconds to hours, that's fine. You can do this in 2 steps. We can go 60 seconds equals 1 minute. And then we know 60 minutes equals 1 hour. So we can do this in 2 separate steps if necessary. Otherwise, you might know already how many seconds are in an hour. If you do, you can go ahead and use that conversion rate. But I'm going to show you it in 2 steps because not everyone knows that off the top of their head. All right, so we need the 60 seconds on the top so that it will cancel out with the seconds that were on the bottom originally, meaning that our 1 minute has to go on the bottom here. That's our blue conversion rate. And then we're trying to go from minutes to hours, so we need our 60 minutes on the top so that it will cancel out, meaning that the 1 hour is going to be on the bottom. That's this purple conversion factor here. And now we're in our hours, which was what we wanted. So we can go ahead and stop and multiply straight across. So on the top, we have 5.6 times 1 kilometer times 60 times 60. Let's use our calculator. 5.6 times, we don't need to put times 1, times 60 times 60 equals 20,160 kilometers. On the bottom, we have 1 times 10 to the third times 1 times 1. That's going to be 10 to the third. And the units on the bottom are hours. Now we need to convert this. We can't leave this as 20,160 over 10 to the third. So if you want to just go ahead and divide it in your calculator, you can, or you can use your exponent rule if you remember how to do that. We get 20.16. And we're going to keep this kilometers per hour. That's your final answer. All right, finally, the last one is also a speed question, except this time, instead of going meters per second to kilometers per hour, we're just reversing that. We're starting out in kilometers per hour. We're converting to meters per second. Those are the common speed units you're going to see in physics class. So that's why we're going to practice these going both ways between each other. Just like before, you're going to start with the given 25 kilometers per 1 hour in the first fraction. And we'll go ahead and convert our distance units first. We know just from the last problem and from the table that 1 kilometer equals 10 to the third meters. But this time, kilometers is starting out on top in the first fraction, so we want to put kilometers on the bottom in the second fraction so that it'll cancel out. The 1 has to go with that, so we put the 1 kilometer on the bottom. The 10 to the third meters goes on the top. Okay, so that takes care of the distance conversion. Now we still have to convert the time units. This time I'm going to go ahead and show you the way to do it all in one step. So you might have figured out from the last problem, or maybe not, that's okay too, that 3,600 seconds is equal to 1 hour because 60 times 60 equals 3,600. So we're going to go ahead and use that conversion factor that 3,600 seconds is equal to 1 hour. And I guess I shouldn't put the R on there. It should just be 1H. Okay, so in order to use this, let's go ahead and highlight that in pink. That was my pink conversion factor. And now I need to look at this and say, okay, the hours is on the bottom in the first fraction, so I know I need to put the hours on the top in my other fraction. So if the 1 hour is going on the top here, that means my 3,600 seconds needs to go on the bottom. You always put one of the conversion factor on the top and the other part of the conversion factor on the bottom. And you just have to make sure you put it so that it cancels out correctly. Now go ahead and multiply straight across. On the top we have 25 times 10 to the third meters. On the bottom we have 3,600 seconds. And you need to divide 25 times 10 to the third divided by 3,600. Oops. 10 to the third divided by 3,600. And it gives us 6.94 repeating. So let's just go ahead and round that. It's about 6.94 meters per second. And that would be your final answer there. Okay, so you've learned how to convert a lot today. You're going to have a lot more practice with this. Converting can be tricky, but as long as you remember to start out with what you're given in the first fraction and make sure to line up your units correctly so that they cancel out, that's the big ideas here. So we'll keep practicing, but hopefully you learned a little bit or reviewed a little bit of this today and that was helpful. Talk to you guys again soon. Bye.